So this one is summer 19 paper, May June 2019 paper. I will do the organic chemistry question as about 25% of this paper 4 based on organic chemistry. The structure of 5 alkenes are shown, as you can see, A, B, C, D, and E. What is the journal formula of alkene? So the journal formula of alkene, they always contain the number of the hydrogen are twice as compared to number of carbon. So if it is Cn, then H should be 2n. Then part B, deduce the molecular formula of alkene D. Molecular formula means which actual number of atoms. So when we check the structure, 1, 2, 3, 4, and 5 carbon. So if there are 5 carbon, even without counting, I can say that it will have, I can count as well, but because we know the number of the hydrogen should always be twice as compared to number of carbon. So if there are 5 carbon atoms, then it should have 10 hydrogen. So you can directly write C5 after counting the carbon. You can just write 10 hydrogen or double hydrogen will be there. Or you can also count 3, 4, 5, 6, 7, 8, 9, and 10. Molecular formula actually represent the actual number of atoms. So you can either count or you can deduce by using the general formula, which is Cn H2n. Then predict which alkene A, B, C, D, or E has the highest boiling point. An explanation. The boiling point of organic compound increases as the number of the carbon increase. Like higher the number of the carbon, more carbon atoms are there, higher boiling point. So increase in carbon number increases the boiling point. So we have to check which one is having the highest number of the carbon atoms that will have the highest boiling point. So this is having only 2 carbon atoms. This one is 3 carbon atoms, 4 carbon atoms, 5 carbon atoms, and this is having 6 carbon atoms. So E is having the highest number of the carbon atom. That's why it will have the highest boiling point. Then which alkene A, B, C, D diffuse most quickly? The rate of diffusion depends on what? So here here E was the answer, and because it is having more carbon or greater carbon more carbon atoms. So which alkene A, B, C, D, or E diffuse the most quickly? Diffusion depends on the inversely proportional to mass. The rate of a diffusion and molecular mass is inversely proportional. So the one which is having the smallest mass will have a highest rate of diffusion. So it is obvious the one which contains few carbon atoms will have a lower mass. So A will have a smaller mass because it is having few atoms. So lighter gases diffuse faster. So the answer here, which gas diffuse faster? That is A. And the reason is that it is having a small molecular mass or lower relative molecular mass. A student added a aqueous bromine. So this is actually a test to check the presence of a double bond. Whenever we have alkene undergo addition reaction. So what will happen if we add bromine, aqueous bromine? If it is a liquid bromine, it is red brown in color, but it is aqueous bromine. Aqueous bromine means water is also there. So aqueous bromine is originally orange in color, but when it reacts, because bromine is removed, turned into like combined with alkene. So what is the color change we will observe? It will start with orange, and the final color, it will be colorless. There will be no color. Then then we have to draw the structure of the product. So remember, whenever any alkene react with a bromine is Br2. So there is always an addition reaction. Bromine Br2 means one bromine added to the carbon, which is the first carbon, which is having a double bond, and the second bromine is added to the second carbon, which is having a double bond, and the double bond will break. So what will be the product here? The same structure, the similar structure we will draw. First draw the similar structure, but without a double bond, because due to a reaction, the double bond will break. And the bromine, two bromine atoms are there, each added to the carbon, which is having a double bond. So one bromine, and you can make it any side, you can make up, you can make down or right or left, that does not make difference. So one bromine added to first carbon, which is having a double bond, and the second bromine added to a second carbon, which is having a double bond. But in the question, they said show all the atoms and all the bonds. So we have to draw the structure and represent all the atoms and all the bonds. So how the structure should appear? The double first, whenever an alkene react, the double bond will break. So this is CH2. CH2 means 2 hydrogen it contains. And then next is CH3, so it contains 3 hydrogen. And this contains 1 hydrogen, and the double bond break. And as a result, one bromine added to the first one and the second bromine added to the second one. And this is the addition reaction which occur whenever any kind of alkene reacted with aqueous bromine or bromine water. Two different alcohols can be produced from alkene by addition reaction. Draw the structure of two alcohols. So when alkene undergo addition reaction, what is the condition here? Any alkene is there, it reacted with steam. Steam means H2O, or we can say H and OH. So what is the possibility? The two possibilities may be hydrogen added to the first and OH added to the second. That is one possibility. Or what is the second possibility? The double bond will break. OH might add it to the first carbon and hydrogen might add it to the second carbon. So we have to draw two alcohols which can be formed during this addition reaction. So what are the possibilities? That the same structure will draw whenever alkene react, the double bond will break. So you don't have to draw a double bond. It will turn into a single bond. Now, first, what might happen if hydrogen added to the first one and OH is added to the second one? So if hydrogen added to the first one, here it will be H and this will be OH. This is one alcohol. What is the second alcohol could be formed? That OH might be added to the first carbon and H might be added to the second carbon. So we'll draw the same structure but without a double bond. And we have to represent all the bonds and all the atoms. So what might happen? OH might be added to the first one. So OH might be added to the first carbon and H might be added to the second carbon. So these are the two structures, two possible structures of alcohol which could be formed when addition reaction occur with steam. The next part is state the reagent and the condition. So what reagent, what chemical we use here? We use water, or you can say steam. And what are the conditions? This reaction occur at high temperature in the presence of phosphoric acid as catalyst. You have to learn these reaction conditions for hydration of alkene. Reagent means the chemical and the conditions which allow the reaction to occur. Then alkene C can be converted into a polymer. We can convert into a polymer, state type of polymerization occur. As I mentioned, if the carbon-carbon chain will be there and alkenes always undergo addition polymerization. So this will always be an addition polymerization. Suggest the name of polymer. The polymer is always named after the monomer. So we have to first identify the name of the monomer. So what is the name of the monomer? 1, 2, 3, and 4 carbon. So for 4 carbon, it is but. And the carbon is with the first and the second carbon, they have a double bond. So it is but-1-ene, or we can say butene. So monomer is butene. The polymer is always named after the monomer. So if monomer is butene, the polymer will be polybutene. And the name should have ENE for a polymer as well, because it represents the name of the monomer. So from first we identify the name of monomer. The small molecule is called a monomer. And from monomer, we identify the polymer. Just add the word poly, that it is a polybutene. Then complete a chemical equation to show the polymerization. What happened in a polymerization? The double bond will break. You will draw the same structure, but without a double bond. The same structure we draw, but without a double bond, and put a bracket N. What does it mean? It means that this chain, the structure continue till the nth molecule. And state the empirical formula. Yesterday we did the empirical formula of the polymer is same as the empirical formula of all the alkenes, which is CH2. So whenever you have any alkene as a monomer and it form a polymer, the empirical formula of the polymer is always CH2. Because when you count the number of hydrogen here, 1, 2, 3, 4 carbon atoms are there, and hydrogen 3, 4, 5, 6, 7, and 8. So C4H8. So when you take a simplest ratio of 4 and 8, you will always get CH2.